Hi everyone, welcome to the bootcamp course for Robo Soccer. This will be a part of series where we are going to learn how to make our own soccer robot. So there we will learn how to assemble a robot and how to make the code for it. Understood? So this will be the part 1 of the series, and in this session we will learn different things. So I hope you all are ready and excited to learn new things, right? So let's start then without wasting any time. So let's start our session. In here, you can find some prerequisites. There, the first one is Power Plugin. We already provided you a kit, so there we will be having a board in it, which is called Kreno board. It requires some additional power to work. For that, we need a Power Plugin point, so where we need to connect the adapter with our Kreno board. Okay, so basically we need a Power Plugin socket where we can connect the adapter. And the second one is the proper internet connection. There you need to have a stable internet connection. And the third one is for connecting to the internet, if you are using your mobile hotspot, there you might require another mobile phone for installing the mobile application for controlling our robot. Understood? So these are the 3 points which are very important, and the last one is Arduino Cloud Editor. So there we are using a cloud platform for developing the code for our board. So for that purpose, we need some credential for getting into this website. So these are the things which are important, and you have to keep this in your mind. Okay, so let's start our session. As I told you, this will be the part 1 of the series, and here in this session we are going to make a Robo-Blinker. So basically, at first we are going to construct the robot. We will make the basic construction of the robot, and then in the next part we will learn how to make a Robo-Blinker. Okay, so there we will learn different concepts, like we will talk about what is robot and what is robotics, and then what are the components which are required for making our robot. And we will learn about the software. There we are using Arduino Web Editor, and then blinking LED program setup. So we will learn how to make a simple code for blinking LEDs. Okay, so there we will be having onboard built-in LEDs in our Kreno board, and we can turn it on and turn it off in each intervals. So that's what we are going to make today. I hope you all understood. Then let's get into it. So this will be our Robo Soccer event looks like. There you can see 2 robots are facing each other, and there you can have a ball, and here you must carry the balls to the other side. So that's how this Robo Soccer game works, right? Yes. So what are the applications of making these robots? So basically this project is a great way to learn about robotics, mobile app, and then the communication between this mobile app and the robot. So you will learn how this robot is communicating with the mobile app. So basically while constructing Robo Soccer, you will get to know these many things. And also here you can participate in the soccer game, and you can control the robot by using a mobile application. So if you want to make your own robot which can be controlled using a mobile application, there you can make a robot like this. Understood? Great. Now let's talk about what is robotics. Robotics is the branch of engineering where it deals with, or it involves, the design, construction, operation, and the use of robots. Yes, so there we will learn how to make a robot by understanding this concept. So at first we must have an idea about the robot that we are going to make. So that's what it is saying, the design. So we must know the design of the robot that we want to make, and then the process goes on. Here in the next step, we are going to construct the robot, and there it must have an operation, so it can be used for different applications, right? Yes. So basically these stages are involved in the field of robotics, from the designing to the use of robots. Understand? Yes. So then let's continue. In the next step, we will talk about what is a robot. A robot is a programmable machine. It can be reprogrammed. So it is a machine itself, and we can program it according to our need. So different robots are there in industries, in health sector, different robots that we can find, right? In homes and all, we can find different robots. You can see the cleaning robots and all, right? So these robots are used for different purposes, right? So these purposes can be assigned by human. So we can program it according to the need. Okay. So these are all reprogrammable machines which can be programmed and act accordingly. Understand? Yes. So a mechanical device that performs human task. So mainly these robots, these machines are used for reducing the effort, right? Yes. So here the robot, the word comes from the word robota. Okay, it stands for forced labor. So what are all the jobs that we are doing? We want to make things easier, right? So there we are using different machines. In this case, we can talk about robots. So robots are the reprogrammable machines which can be used in varieties of fields, right? Yes. So I hope you all understood what is robotics and what is a robot. In this session, we are going to make a simple robot, and this will be a basic construction of our Robo Soccer. There it involves the assembling of the robot. Understand? Yes. So now when we are talking about the future of robotics, there you can see Vyomitra, Sophia, these AI teachers in our schools. So Vyomitra is a robot which is designed by ISRO. So Vyomitra is a semi-humanoid robot which is used for helping the astronauts. So basically what it can do is it can provide the informations related to the space and the machineries used in the spacecraft. And also, so it can provide the communication in between the people on Earth and on the space. Okay. And then the Sophia comes. So we all know about Sophia, right? Yes. So Sophia is the robot which got the first citizenship from UAE. So mainly this is a robot and it can mimic human intelligence. What and all the things that you are talking. So it can give you the answer accordingly, right? Yes. So these are happening right now and we can expect more in future because there we are implementing AI with robotics. Fine? Yes. So in this session, let's assemble the robot at first. So these are the components which are required for making the robot, and these many components are there. So in here, these are the components that you may find in your kit. So you can take it out. So you can take the robotic kit with you, and what you can do is you can put it on the side. So what and all the components that I am explaining, that you can have a look into it. Okay. So at first here you can see the Kreno brick, which is the main part of the system. It will be acting as the brain of the unit. And there you can find bottom acrylic shield and the top acrylic shield, which are used for connecting the Kreno brick. Understand? Fine. So when it comes to the other parts, there you can find caster wheel, metal spacer, plastic washers, wheels, BO motor with case, extension cable, RJ11 cables, USB cable, 12-volt adapter. These many things will be there, and spanner, Allen key, and screws and nuts. These many items will be there. Understand? And what you can do, you can take it out everything and you can follow my instruction and you can do accordingly. Fine? Great. So at first we should know what is Kreno board. It is the India's first AI and IoT enabled board. So you can use this board for multi-purposes. Like if you want to use it for robotic projects, you can use it. If you want to use it for AI, you can use it. And of course, you can do IoT projects with this one. So you can use it wisely according to the purpose. Okay. So this board is multi-purpose and you can use it in these fields. And here, this is an advanced version of ESP32 microcontroller board. So there you can see here, this is the microcontroller unit, which is called ESP32, which is having inbuilt Wi-Fi and Bluetooth module in it. Okay. And these many pins which are taken out. So these are the ports. So these many ports are there. You can see that 3 ports for connecting DC motors. So these are the 3 ports, one here and 2 in here. And there are 5 ports for connecting different sensors. So the 5 ports are 1, 2, 3, 4, 5. So these are the 5 ports and these are all used for connecting different sensors with RJ11 cables. And here this part is called GPIO port. So this will be used for connecting external devices like any other sensors. If you want to directly plug in this one with our Kreno board, you can use it. You can use this GPIO port. Understand? So the pin port and connections are taken out. So here you can see that this is the pin diagram where you can identify the pin numbers by looking at it. See? So this is the GPIO port that we explained, and here you can find these are the pins of the ESP32. Okay, so this is our Kreno board, and this is the board which will be acting as the central processing unit of the robot, or the brain of the entire system. So what and all the program that we are making, it can be uploaded into the board, and the rest of the things will be done by this board. Understand? Yes. So let's start to make the robot. As you can see here, these are the important things which are required for making our basic construction of the robot. Here you can see this is the microcontroller board, which is our Kreno board, and there you can see it is attached with the top acrylic shield and the bottom acrylic shield. So this is how it came, and then there you can see two motors are attached to this end and this end. And the thing is that these are all attached already, and what we need to do is we need to connect the rest of the things. So the next one will be the soccer acrylic shield, which is used for connecting this part with the main board. Okay, so it will be connected like this, and you can see that two wheels are here. So these two wheels can be connected to these motors, and then there you can find this caster wheel. So why we are using this caster wheel? Yes, on the front side. So here this caster wheel can be attached, so it can move around easily in any direction. So it can move around in any direction like this. So that's why we are using this caster wheel with our board. And then there you can find some screws are there, two medium screws and two small screws and nuts. And then this is an Allen key which is used to tighten the screws. Okay. Now let's assemble the robot. So at first let's attach the caster wheel with our board. So how we are going to connect it? So there you can find on the bottom side of this robot, you can see two metal spaces. See here. So these are the batteries for powering up the board, and here this is the metal spacer. Okay. So what you can do is you can connect the caster wheel with this metal spaces like this. So this is how you need to connect it. Okay. So this will be the front part. So this will be the front part. So this rolling section should be going bottom side, and it will be like this. So then it will move. So that's how we are going to make. And now what we can do is we can put this one like this, and we can insert two screws in here. So there I am using two small screws. So these are the small screws that I am using, and let's put it in here into this hole. So you should align these two holes and then put it like this. Okay. So when you rotate it clockwise direction, you are screwing the screw, and then again from here let's rotate. Yes, it went inside. Now what we need to do is we need to tighten the screws. So let's use this align key and rotate it clockwise direction. Okay, now it is fixed over there, and in the next step what we can do is we can put this one like this, and here you can see that the structure will look like this. Okay, now what we can do is we can attach these wheels. So let's attach these wheels. So while attaching the wheels, you must ensure that this shaft, there is a small structure that you can see. It is like a rectangle and a circle mixed. So what you can do is you can see that it is also having a shape like that. You must align this shape each other and then press it. Okay, then it will be fitted into the shaft. In the same way we are going to add the second one. So let's put this one, and yeah, it is fixed. Now when you are having a look at this one, see here, it will be like this. The caster wheel is this side, and this will be the front side of the robot, and these are the back side. Okay. Now here you can see the battery connector, and it should be going in this place. So we are not connecting it right now. So we will do that later. So the basic assembly is not done yet. We need to connect the soccer acrylic shield. So let's attach this soccer acrylic on the front side. Okay, like this it should be going. So when you're having a look at this robot from the front side, you can see it will be like this. So this will be the acrylic shield which will be connected to the front side and it can carry the board. So let's attach this one. So how you will attach this? So there you might require medium sized screws. So what you can do, you can just simply insert this one into these 3 holes. So here we need to take these 2 holes on this side and this side. Okay, so let's connect this one like this. So what we have to do is we have to place this one here and then simply insert the screw. Okay, so simply insert the screw upwards and then there it comes. And in the same way we need to connect the second one. This is how it looks like, and now we need to use the nuts. Okay, so let's use the nuts. So simply rotate this one in clockwise direction. Now the other one. Okay, so let's insert this one in here and rotate. So once it is like this, what you can do, you can turn it around and then there you might need to use this Allen key. So you can tighten the screws by using the Allen key like this. So you can put a finger in here and then use the Allen key to tighten the screws. The same way is the second one. Rotate the screws in clockwise direction. Then here, this is how it looks like. Now it is fixed. So I hope you are done making our basic construction of the robot, right? Good. So now let's continue. So as a part 1 of the session, we made the basic assembly of the robot, right? Yes. And in the next step, what we are going to do is we are going to light up the built-in LEDs in it. So where did you find the built-in LEDs on the board? So I will show you. So when you have a look at this board, there you can find M1, M2, M3 over there, right? So there we can have 6 LEDs in total. In the sense, these pins are used for connecting the motors, and the motor pins are 25, 26, 19, 15, 32 and 33. So these 2 RJ11 ports are used for connecting these 2 motors. Okay, and these motor pins are 25, 26 and 19, 15. Okay, basically here you can find the LED pins such as 25, 26 and 19, 15. So these LEDs are connected to these 6 pins. Okay, so when there are any voltage changes in these pins, in the motor pins, it will be also affected by this LEDs. Okay, now let's see how we can light up the LED which is connected to the 25th pin of our Kreno board. And then there we will be making another program which is used for blinking the onboard LED. So let's see how to do that. So now here at first let's see what is a programming language. There you can see a man is waving at us and then he is telling something. Okay, the one sentence is hola como estas, which is in Spanish, and the other one is hi, how are you? Both are same, but both are in different languages, right? Yes. So there you can see it is written over there in English. So that's why we come to understand that he's asking hi, how are you, right? In here, if you don't know the Spanish language, we don't come to understand that what is he saying in hola como estas, right? Hola como estas. It is the same as hi, how are you, right? Yes. So the thing is that when you're talking to a person or if you are communicating with a person, the person should understand the language that we are using, right? Yes. The same way, if we are communicating with a machine or a computer, there we need to use the language which can be understood by this particular machine or computer. Okay. So that's why we call the language as programming language. So the language used to program or the language used to communicate with the computer or the machines can be said to be a programming language. Okay, so now you understood what is a programming language, right? Perfect. So now when we are entering into the coding area, there we need to discuss about what is an algorithm. Algorithm is a step-by-step process. It is the step-by-step instructions which are taken for achieving a task. Okay, so there you can see that a mother is giving instructions to her child about brushing her teeth, right? There you can see the instructions like step 1, step 2, step 3 like that. So there you can find the order. These orders are jumbled that you can see over there, which is indicating if you are doing these steps in order, like in the same way which is written over there, it will be a mess, right? So we can't achieve the task according to our need. So if you are doing an activity or if you are achieving a task, so there you must undergo different steps, and these steps should have an order. The order of instructions is very important. Okay, so when you are preparing an algorithm, there you must use the order of instructions accurately. Okay, so the algorithm is the step-by-step instructions that can be taken for achieving a task. Understood? Great. Now let's talk about what is coding. So we talked about what is an algorithm and programming language, right? So these instructions which can be given to a computer, that is called coding. So there we are providing step-by-step instructions to a computer to do a particular task. So in here the instructions, the step-by-step instructions can be given to a computer. So these instructions can be given to a computer by using any programming languages. Understand? So what we are doing is we are giving instructions to a computer to do a particular task. So that's what coding refers to. Understand? And here you can see that there are types of coding. The one is block coding and the other one is text-based coding. Now in this session we are using text-based coding language. So let's see what it is. So in here, if you want to work with this coding part, there you might need to use Arduino Cloud Editor. So Arduino Cloud Editor is a web-based software for different boards like Arduino boards, ESP32 boards, ESP8266, like etc. Okay, so now when it comes to this Arduino Cloud Editor, it is to write the code and we can save it to the cloud. So there we will be having an account in this Arduino Cloud. So here the cloud editor can be used to write the code and we can upload it to the board and it can be saved in the cloud itself. So when you want to use it again, what you have to do is you have to log into this account again and you can take it from the cloud. Okay, it's that simple. It will automatically recognizes any board connected to your PC and configures itself accordingly. So what are all the boards that we are using, it will automatically detected by the Arduino Cloud Editor. Understand? Great. So now let's see how we can use it. So there you have to go to this particular link, which is app.arduino.cc. The link is already provided in the supporting material and you can get it from there. Okay. Or else you can directly search for app.arduino.cc and then you can go to this sketches. Understand? So when you click this web link, it will be taking you to a simple interface which will be like this. So there you can see welcome to Arduino and then there you have to use your Google account ID. Okay, so when you are using this Google account ID, there you have to provide a username for it. So let's see what are the steps which are needed for making an account in this Google Cloud Editor. Okay, so at first you can click onto this Google mail ID or else you can directly put the email ID and password in here to sign in. So let's use this one. So there you have to give your mail ID and all, and there you have to provide the password for it. So if there is any verification, you have to click yes and then let's continue and it will be taking you to the interface. Okay. So now when you are entering into this cloud editor, there you have to provide the username. You need to give the username with capital letters and small letters, and if it is saying error, you have to identify what it is saying and then you can provide the username accordingly. Okay, then only you can enter to this interface. Understood? Yes. Now, once you are in this phase, what we can do is we can go and create new sketch. Let's go and create new sketch. So every file inside here will be called as new sketch or sketch. So let's create a new sketch. Now let's create it. And here you can see that it is asking for some permissions. So if it is required, you can give it. Okay, so let's close this one. Here you can see that it is asking for to see the text and images that we copied it to the clipboard. So let it be like, yeah, make it as allow. And then here, this is the mobile cloud editor you can find. So this will be the window that will come first. Now let's click continue, and then you can hide this one. And this will be the new sketch, and this will be the interface looks like. Okay, now what we can do is, at first we need to select the device. Okay, so we should select the device at first, then we can make the code. So this will be a simple interface, and this is where we are going to type the program. Here you can see a compiling tool is there, which is used to check whether the code is okay or not. And after that, you can see an uploading button. An uploading button is there, which is used to upload the code to our board. And here you can see that a message is saying no cloud agent connection. So what you have to do is, there we need a software which is cloud agent, which is used for communicating with the hardware, which is our Kreno board, and with this web editor. And for that purpose, we need to click the learn more option. And now let's go to this install the Arduino Cloud Agent option. Okay, so it will take you to another window, and when you click onto this install Arduino Cloud Agent, there you can see a download option. So what you can do, just click on it and it will be downloaded. Here you can see it will be downloaded over there. So once it is downloaded, you can open it. So once you click onto the executable file, it will be asking for you to set up the Arduino Cloud Agent. So what you can do is, you can click next. Again, here you must accept the agreement, and then click next. You can give the file location as default, and then next. It will be installing the driver or the cloud agent, and then now it is installed. Now the setup is completed. You can click finish. Okay, now let's go back to this one. So we installed the cloud agent. Now here you can see that device not found. So what we need to do is, we need to connect the device with our web editor. So for that purpose, at first we need to power up the Kreno board, and then we can use the USB cable to connect the laptop or the computer with our Kreno board. Understand? Let's connect it with the USB cable. As you can see here, this is our robot, and there you can find a DC jack which is used for connecting the power adapter. So let's connect the power adapter to this point. So you have to plug in this one, and there you can find this board is now powered up. Okay, so once it is getting enough energy, the board is now ready, and in here we should turn on this slide switch to make the Kreno board work. Okay, so if you want to upload the code, what you have to do is, you have to turn on the switch. And in the next part, we are going to connect the USB cable with our robot. So what you have to do is, you have to connect this micro USB cable with our Kreno board. So there you can connect this end to this point like this. Okay, so now it is connected, and here the other end of the micro USB cable is going into our computer. Okay, now we should turn on this switch. So let's do the coding part now. So in here we attach the COM port, and then when you are going into this one, it's again saying device not found. You have to select the device from here. So let's select the device. So here it is saying it is an unknown device which is connected to COM5. Okay, so what we need to do is, we need to select the device. So let's select the device by going into selecting the device, and then you can search for ESP32 dev module. Okay, so when you search for ESP32 dev module, it will be coming like this, and then you have to choose this ESP32 dev module. So once you select it, now the device name is written over there. Can you see that? Yes, right? Now our board is set for programming, and the COM port is already connected. So this is the coding area where we are going to develop the code. So before going into coding, we need to cover some coding concepts. So there you can find two functions which are setup of and loop of. So these two brackets indicates it is a function or it is having a special keyword. Okay, that means it has to do something. Okay, each and every sketch has setup and loop of functions. Without these two functions, no sketch will work. So the two important functions are setup and loop. So these curly braces indicates what and all the instructions are coming under this function, it will be written over there. So inside these brackets, we should write the instructions which is used for working with our robot. And here the loop also the same. Inside these curly braces, we should mention what are the things that we needed and it will be executed. So what is this function? What is this literal function means? The thing is that, so if I have a pen, the function of the pen is used to write, right? So particularly it has something to do. The same thing comes here. So whenever, if I am calling this one, it will be having a sort of program which is designed to do a task. Okay, some instructions are there and it will be executed accordingly. So that's how the functions will work. So when we call the function, what and all the instructions inside of it will be executed automatically. Okay, so now what is the difference between this setup and loop? So there the setup function will only run once when the board starts up. Okay, it will be executed only once when the board starts up. So what and all the instructions inside of the setup function will be executed for once. Okay, and after that it will be stopped. Directly after that it will be entering into this loop function, and what and all the instructions inside of this loop function will be executed continuously. So it will be a loop. So one by one the instructions will be executed and then it will be coming back to the first instruction which is inside this loop function. Okay, so that's how it will be executing the code. Now here in the setup function, if you want to turn on the LED on the board, there you might set the pin as output or input. Okay, so we all know that LED is an output device which takes the data or which takes the electrical signal and it works. So we need to provide the signal to the LED. So we are providing the signal to the LED or the electrical pulses to the LED to work with, right? So the mode of this LED pin will be output. Okay, so there we need to use another function which is already declared before, and what we need to do is we only need to use the same function. So the function name will be pin mode. So you should write the same program in here, pin mode. So while writing the pin mode function, ensure that wherever I am using the capital letters, you have to use the same. Wherever I am using the small letters, you have to use the same, because these are all special keywords which can be understood by the compiler inside this one. Understand? Great. Now we all know that it is a function. Of course, it will be having a bracket. So inside of this one, we need to give the parameters. The parameters are, or the arguments are, pin number and the mode. Here we are controlling the pin number which is connected to the motor one, which is 25th pin of our Kreno board. So we have to mention the pin number as 25. So let's make it as 25. 25, comma, let's put it as output. So if you are writing output, there you have to use the capital letters. Okay, so we are setting the mode in here. So let's close it. Let's close the instruction. So after writing every instruction here, you must use a semicolon, then only it will be ended, because here we are using simplified C language and it will be using the C programming language concepts. Okay, so that's why we need to use the same here. So in C programming language, every instructions are ending with semicolon. Now what we did is we made the 25th pin as output. So I hope you all are writing the code, and so you wrote this one, right? Great. So we set the 25th pin as output in this step. Now what we need to do? We need to light up the LED, right? So the lighting part will be coming under this void loop. Okay, so you can directly give it to there. so it will be lighted up. But instead of that, what we are going to do is we are going to write the program in here. Okay, so let's make it on by using another function which is called digital write. Digital write. So why we are using digital write function? Digital write function is used for giving the digital data to the pins that we are providing here. Of course, the pin number is 25. Instead of here, we need to provide it as, we need to give it as 25 and let it be like high. So the second parameter will be high, which is indicating that we are providing a value of 1, which is indicating the pin will be getting a higher voltage of supply, which will be a positive voltage. So the maximum output voltage our board can give is 3.3 volt. So there you can see different digital and analog pins are there. So these pins are working with 3.3 voltage of supply. So if you are giving 3.3 volt or if you are providing it as high, it can give 3.3 volt. Or if you are providing it as low, that means there we are giving 0. So here when we are setting it as high, that means our LED is now getting a positive voltage to the end. So the other end is already connected to the ground. Now the LED will be turned on. So once the instruction is end, let's give a semicolon over there. See, now it's okay. Fine. So at first let's upload the code and see what is the result. Okay. So how you can upload it? Directly go to this one, and before that, when you want to verify it, you can click on to that. So it will verify the code that is written, because if there are any errors, we can identify the errors by looking at it or verifying it. And then there is a compiler in it. The compiler will convert this high level language into low level language. Now there is a console window we can find. It's still saying it is verifying the code. So let's wait for a few seconds. So in here, these are the instructions that we provided inside this void setup and void loop. We used pin mode function and digital write function, and pin mode function is used to set the particular pin as output or input. So here we made the 25 or 25th pin of our Kreno board as output, because there we connected an LED. So LED is an output device, so we need to give enough power to work these LEDs, right? So now in the next step, in the void loop, there we give the digital write pin. Okay, so the digital write pin as 25 and it is set to high. High in the sense we provided a voltage across this digital pin, which is the highest value it can provide, the board can provide, which will be 3.3 volt. Okay, so whenever it is getting a positive voltage to this particular pin, the LED will be turned on. Okay, so there it is now done verifying. There are no errors we can find because it is a small set of code. And here before uploading the code, there you can see none of the LEDs are working now, right? So all are turned off. Now let's upload the code and see what happens. So here this is the uploading button. Let's use this one. So once you click onto it, again it will be compiling the code or verifying the code, and then only it will be uploading the code into the board. Okay. So now here, before uploading the code, you have to ensure that these cables are disconnected from the ports, RJ11 ports, because these are connected to the motors. So whenever we are using the pin numbers which are connected for motors, so the direct power will be given to the motors, then it will be move away. So for excluding it, what we need to do is we need to remove these cables at first. So we will use these motors in the next session, the next part. So for this session, we are only using the LEDs connected here. So now once it is connected, let's upload the code into the board. So let's click onto this upload button. So we clicked it. Now again, it will be verifying the code. The console says it is verifying. After the verification, we will see the code will be uploaded to the board. Here you can see now it is started to upload. Yeah, now the uploading has been started and now it's over. You can see it, right? So the Code is now uploaded. Now let's see what will be the output looks like. As you can see here, the M1 pin. So there are two M1 pins, 25 and 26. We are only using 25 pin here. So the LED connected to the 25th pin is now turned on. You can see it over there. See that? Yes. Now we need to make the code for blinking the LED. So let's see how we can make it. So for making a blinking LED program, we need to know the logic of it. So at first, the LED pin should be kept as high for a particular period, and then after that, it should be turned low, or it should be turned off for a particular time period, and then the cycle continues. Then only it will be a blinking LED program. And this is what it looks like. So what we are going to do is we are going to provide a delay here, a delay in milliseconds range. So for giving the delay, what we can do is we can use this delay function, and we all know that the function includes these brackets, and inside this bracket we need to give one parameter or one argument which is in millisecond. Okay, so we need to provide it as milliseconds. So 1000 milliseconds indicates 1 second. Okay, so after giving the delay, what we can do, we can write the next digital write. So what is happening here is, after executing this first instruction, it will be waiting for 1 second here, and then it will execute the next instruction that we are going to provide. Okay, so it will wait for 1 second here before executing the next instruction. So let's provide the next instruction, which is digital write. So here in this digital write, we need to make the 25th pin as low, which is indicating there is low voltage. So the LED will be turned off then, and then again we need to provide a delay. So after providing the delay, we can ensure that the LED is now turned on and off for a particular period of time. Okay, and now here what we need to do, we need to set the 25th pin as low. So 25 comma, there you have to provide low. Okay, instead of high, we are providing low for setting the voltage level as 0. Okay, now it is 0. We can close this one, digital write 25 low, and then we need to provide another delay which is for sticking on to this low state for 1 second. Okay, so we need to give it as 1000 milliseconds, which is indicating 1 second. Now it is perfect. The coding is all set. Now this is the blinking LED program for our Kreno board. So let's upload the code and see what is happening. Now the code is compiling. After compiling, it will be uploaded into the board. So let's wait for a few seconds. The uploading has been started. Now it is uploading the code into our board using the COM port. Yeah, it is started now. Now it's done. So now let's see what will be the result that we can see. So once you upload the code into our board, there you can see the 25th pin LED is now blinking in each 1 second interval. See that? It is turned on for 1 second and turned off for 1 second. So depends upon the delay that we provided, it will act accordingly. It will turn on and off according to the value that we are providing. So this is how we can control each pins of ESP32 in this Kreno board. Okay, so we used 25th pin. Likewise, you can use 26, 19, 15, 32 and 33 pins. Okay, this is how you can make use of each individual pin to control the supply voltage. So basically in this session we learned how to assemble the robot using the components, and here we used this editor window, which is Arduino Cloud Editor window, to write the code and to upload the code into our board, right? So there we used different coding concept. We used functions such as pin mode and digital write and delay of functions, right? So this pin mode function is used to declare the particular pin as output or input, and we set the mode of the particular pin using the pin mode function, and then the digital write function is used to control the digital pins value such as high or low. Okay, And the delay function is used to give the time delay in milliseconds, right? So in here, in this part, we learned how to make a Robo-Blinker using the Arduino Cloud Editor, right? Yes. So in this session, we learned about robots and robotics, and we familiarized what are the components inside our kit, and we assembled the robot, and we familiarized the software used for coding purposes, and then we made a blinking LED program. So likewise, you can do many things with our Kreno board. Okay, so the thing is that you don't need to change the code that we developed today, because this session will be the part 1 of making our Robo Soccer, and there are sessions coming. So we will use the same sketch for developing the code for our Robo Soccer. So what you have to do is you have to keep the same sketch as like that, so we can develop the code in the same sketch. So if you want to play around with Kreno board, you can take a new sketch and you can start doing coding in it. Okay, fine. And if you're thinking about the Robo Soccer making kit, don't worry, we are here. Now you can purchase our exclusive DIY Robo Soccer kit just by contacting us. Thank you all. We will see you next time.